Okay, so in the journal we were doing two models that show different densities. Just kind of reviewing. And so we know that mass is the amount of particles, it's the amount of stuff in an object. And Adrian told us we show that by making dots. All right, what is volume? Thank you. How much space? Something takes up. Raise your hand if you can tell me how we show that in a model. Michael? The size of the object. Yeah, could we make a really big cube? Could we make a really big square? Rectangle? Real big circle? Sure, any of those work. Let's make them different sizes. All right, so talking about density, and these are the two variables involved. Could I make two models that had the same mass but different densities? I could. Can somebody volunteer and answer how I would do that? Nathan. Ooh, okay. 5 big dots. Like this. Why do you say that? Okay. So it's the same amount of dots. So each one has 5 dots. But these dots are larger and they take up more space. And so it has more density. Is that what you say? Okay. Everybody agree with that? That's the best way to show that, I think? Gianni, what did you say? Gianni said she would change the volume. Would you change the size of the dots? So I could do make a big one, which means large, high volume, right? And make a small one and still do the same number of dots. Is that right? Because we got to have the same mass. So if they're the same mass, say this is object A, this is object B, same mass, so same number of dots. But if I make this object larger, one thing I don't want to do is this. Does that make it easy to see different densities? The dots are supposed to be all the same size. It's just when I tap the board, sometimes they go smaller dots, sometimes they're larger dots. Is that a good way to show it? Why? More spread out. So if I have all this available space to use it. All right, so I've got a bigger volume, and I'm going to use all that space. Does that look like a good way of showing two objects that have different volume but the same mass? Okay? And if they have different volumes with the same mass, are they going to have different densities? Yes, they are. What do you think of normally if you just put density into your own words? How would you explain it in terms of particles? Michael? How compact the particles are within the object, would you agree, Sarge? Okay, so which one's more compact, A or B? Okay, B. They're closer together, right? So if something is more dense, more compact. If something is less dense, the particles are more spread out. Now, is what Nathan said necessarily wrong? No, it's not. But here's the deal. For right now, I do not want you guys making different size dots. If you want to show different types of particles, use different colors, but don't use different size dots right now, okay? So can we establish not doing that yet? It is possible you can have particles that are bigger than other particles, absolutely. But I really want you to understand the volume and mass relationship right now. Okay, so if we have less particles taking up a bigger space, that's going to be less dense. All right, so let's talk about this then. Can we do two models in which the volume is the same, but they have different densities? So what would I draw? Say I'm going to draw squares. What should I do with the squares? They should be the same size. Can somebody, thank you, Kate. Okay, so they have the same volume. How are we going to show different densities in the same volume? Anybody that hasn't volunteered yet? How are we going to show different densities with the same volume? Sammy? Different amount of particles. How many should I put in the box on the left? 3. Why did you come up with 3? What does that mean? Just a random number, just 3? Okay, I'm going to use all the available space I can. Kind of spread them out evenly. All right, how many you want in the box on the right? 6. Okay. You want more than 6? Maybe 8? 10? Why is it better to use a bigger number of dots? Easier to see, that's right, thank you. Easier to see. Can I look at this one and say that there's a lot more space in between particles than in this one? If I had just left 6, like she said, would it be wrong? No. Just make it easy to see. No space between particles hardly. So this would be more dense. This would be less dense, less mass. So we kind of see what's happening with this density relationship, don't we? So in the first one, if I wanted to make something more dense, all right, so they had the same mass, but different densities, I changed the volume. If I made the volume here large volume, what happened to the density? Which one has a higher density, the one that's big or the one that's small? The big one. Wait, did I say higher density or less density? Higher density would be this one, right? So with volume, it's like when the volume goes down, the density increases. Ooh, look, what is that? Inverse relationship, that's right. So density and volume have an inverse relationship. If the volume goes up, the density is going to do what? Go down. That's right. So if I took some particles, some silly putty, this would be a good experiment. Took some silly putty and I put it in a glass of water, do you think it would float or sink? Like all wadded up. That'd be a good test, good experiment. And then what happened if I spread it out all flat and put it in water? Maybe. So go home and take your silly putty. I know you guys have silly putty at home. You know, Play-Doh would probably all sink. Is Play-Doh more dense than silly putty, you think? About with mass, then, when we see mass. All right, so which one of these was more dense? The one on the left or the one on the right? Well, the one that says more dense, right? I wrote it down. Okay. All right. Which one has a higher mass? Okay. So we can tell that looks like here, if we have the same volume and I increase the mass, the density also increases. Would you agree with that? Do you think if I decrease the mass, keeping the volume the same, I made the mass go down like I removed particles, that the density would also go down? Yes. So we call that a direct relationship. And you know what works out is in the formula, density equals mass over volume. We can actually tell that we have direct and inverse relationships this way. Because direct, density, and mass are both on the top part of the equation. Volume's underneath from density. So on the opposite side, so that would make it an inverse, but you don't really have to know that yet. You do need to know this formula, though, and you do need to know the units. What are the units for mass? What are the units for volume? Okay, so I could have a couple different ones for density. I could have density equals mass in grams over volume in milliliters, or I could have density equals mass in grams over volume in cubic centimeters. We've worked on these. Okay, this is one thing I want you to start getting used to. When you look at these numbers like these fractions, think of them as division problems, because really they are. They're also ratios. And then you can also think of this line in between, since it's like a ratio, you can think of that as per. P-E-R. You can also think of it as for every, which I've had you do this before. Remember that? For every. So really when you read this, it's saying density is the mass per volume. Or density is the amount of mass for every given amount of volume. Or density is grams per milliliter. And sometimes we just write it, grams per milliliter. That's what that means too. Or density is mass per, grams per cubic centimeter. Okay? If I had a mass of 10 grams and a volume of 5 cubic centimeters, I could also say there are 10 grams for every 5 cubic centimeters. Does that make sense? All right, so when we did those problems the other day, those math problems, so we started out with the first couple, and I said, all right, what's the density if the mass is 8 grams and the volume is 4 milliliters? You could probably just do that in your head, but all right. So let's say the numbers weren't that easy, but just using this as an easy example. So you have density, I'm just going to put D for now, equals mass in grams over volume, which what is volume in this problem? Milliliters. Okay? So all you had to do was just say, okay, the mass is 8 grams and the volume is 4 milliliters. What is 8 divided by 4? 2 grams per milliliter. Pretty easy, right? You agree? We just took the mass and divided by the volume. All right, but then you guys struggled a little bit when I did this. Not all of you, but many of you struggled when I did this. Okay, let's say the density is 3 grams per cubic centimeter. And let's say the volume is 10 cubic centimeters. What is the mass? And then people struggled a little bit. All right, so what we got to do here is it's going to be the same thing. Density equals mass over volume. But now when I fill in my numbers, it's going to be a little different. On the left, I'm going to have 3 grams per cubic centimeter equals m for mass, which I don't know what it is, so I'm going to leave it as m. I don't have a number to put in there yet. And then for volume, I'm going to put 10 cubic centimeters. So this is kind of basic math. I understand that some people in here are really good at math. Other people in here are okay at math. We have m, don't know what it is, we have 10 on the bottom. What we got to do is we got to do two things. Number one thing we got to do is whatever we're solving for, we got to make sure it's on the top part of the equation. So it's not like down on the bottom like 10 cubic centimeters here. Okay? So number one thing is make sure it's on top. Is it on top? Is the thing we're trying to solve for in the top part of the equation? Okay. The second thing we got to do is we got to make sure it's by itself. Right now it's not by itself because it's being divided by 10 cubic centimeters. So the way to get it by itself is do the opposite of having it divided by 10 cubic centimeters. Multiply it by 10 cubic centimeters. Okay? But the rule goes like this. Whatever you do to one side of the equation, you have to do the same thing to the other side of the equation. So if I multiply this right side by 10 cubic centimeters, I have to do the same thing to the other side. That's a rule. You can't change it. Otherwise, you're changing the equation. All right, now what that allows me to do is when you take the mass and multiply it by 10 cubic centimeters and also divide it by 10 cubic centimeters, what you're doing is you're canceling that out. Okay? So you could draw a line through it. Or if you're using pencil, you can just erase it. Okay? So now I can just solve the problem. 10 cubic centimeters times 3 grams per cubic centimeter would be what? 30. What do you think the units are? What do you think? Just grams? What are our units for mass? Grams. Do I have grams in this problem just to double check? I do. Okay, now, I was going over this stuff last hour, and I know some people were still kind of struggling with it, me doing it this way. So here's another thing to consider. Okay, another thing to consider is maybe just do the equation first, and you still have to keep your rules, your algebra rules. So D equals M over V, but maybe it's easier to just identify what you're solving for first before plugging in the numbers. So if I do that, I want to find mass, because that's my question mark. That's what I asked you to find. So I want to get that on top and by itself. I go, okay, it's on top. It's not by itself. It's being divided by volume. Multiply both sides by volume. And so that tells me that the equation for mass is V times density. Does that make sense? And now I could just plug in my numbers. Volume is 10 cubic centimeters times the density, which is 3 grams per cubic centimeter. All right, so 30. I know the units for mass are grams. It could be 10 cubic centimeters times something with centimeters in the denominator cancels that out. That's why. Don't worry if that doesn't make sense to you. All right, and then a lot more people struggled when I did this. All right, so let's say the density is, we'll go super easy, 1 gram per milliliter, and the mass is 20 grams. And then what is the volume? So a lot of people were lost on this. Right, Sammy? Osiris? Oh my goodness. It's on video. All right, so same thing like I did before. If you just start by writing the equation, D equals M over V. All right, so what am I trying to solve for here? Density, mass, or volume? Okay, so I want to get this one on top and by itself, right? Number one, get it on top of the equation. Two, get it by itself. It's not on top of the equation right now. The way you can do that, again, whenever you're having problems, you don't have something, just multiply by it. So I'm going to go times V. But I got to do it to both sides. Okay? Oh, yeah. Right? So I want to get it on the top part of the equation. Let me give this a little more space, too. Kind of congested here. All right? So I've got V on the bottom over here. I've got V on top. V cancels out. So that tells me the equation is V times D equals M. Oh, wait, that's not what we're trying to solve for V, aren't we? So we still have to get it by itself. Why is it not by itself? It's being multiplied by the density. So how do we get it by itself? Divide it by density. But whatever I do to one side, I have to do to the other side, correct? All right. So that cancels out the D over here, and I end up with V equals M over D. All right. So all I got to do now is plug in my numbers. So V equals M over D, which means I'm going to put 20.0 grams on top for the mass. I'm going to put 1.0 grams per milliliter on the bottom. What is 20 divided by 1? 20. What do you think my units are here? Milliliters, because we know the units for volume are either cubic centimeters or milliliters. Which ones do I have in this problem? Milliliters. Okay? And that's some of our density math practice. You can plug in any numbers over here, solving for different variables to get more practice, and we'll also be doing more practice here in class. All right? And that is it.